Kafka is all about streaming data. Messages are produced by producers and stored on a Kafka broker. Messages can then be consumed by Kafka consumers. Today we're going to be taking a look at how to consume data in Kafka. There are a number of things to consider when reading Kafka data. This all depends on how messages are stored and how messages are structured, and ultimately how partitions where these messages are stored are configured. Today we're going to be building a Kafka consumer and be taking a look at these different scenarios and learn how data is consumed in Kafka. We've got a lot to cover, so without further ado, let's go. So if we take a look at my GitHub repo, I have a messaging folder, and in the messaging folder I have a Kafka folder with a consumer.md, and this is our guide to consuming data in Kafka. We're going to be starting a Kafka environment, building our consumer, and then we're going to start it up and then take a look at different scenarios for consuming Kafka data. So be sure to check out the link down below to the source code so you can follow along. Now, starting a Kafka environment is very simple with Docker Compose. If you're new to Kafka, I highly recommend to check out my introduction to Kafka video down below, as well as my introduction to Kafka on Docker Compose. We're going to be firing up one Zookeeper instance followed by 3 Kafka instances in a cluster. And then we're going to create a topic called orders for an online ordering system. So the first step before we begin is starting a Kafka environment. And to do this, we're going to change directory into the messaging Kafka folder. So copy that, paste it to the terminal, and then we're going to start up the Kafka containers as well as Zookeeper. And then I'm going to say Docker Compose up. I'm going to start up my Zookeeper 1 and my Kafka 1, 2, and 3. So I go ahead and run that. That'll create my instances and start them up and form a cluster. Now with that up and running, I can open up another terminal and I can say Docker PS. And then we can see we have all our instances running. We have our Zookeeper 1, Kafka 1, Kafka 2 and Kafka 3. And in the messaging Kafka folder, I have a Docker Compose file, and taking a look at that, you can see how everything is configured. We have our Zookeeper 1, our Kafka 1, Kafka 2, Kafka 3. And if you expand this, you can see how we set everything up. We're running our Zookeeper image, the folder of where that Docker file is, the volume for its config and its data to persist its data, as well as the network it's running on. If we take a look at Kafka 1, we can see it's got a Docker image as well. The Docker file is in the local folder. We have a volume for the Kafka config as well as the data to persist the Kafka 1 data. And then we have the same thing for Kafka 2, but it's persisting its data in the Kafka 2 folder and has its configuration in Kafka 2. The same concept goes for Kafka 3. If we take a look at the side here, we have a config folder with Kafka 1, 2, and 3 for its configuration, a Zookeeper folder for the Zookeeper configuration, as well as a data folder where Kafka 1, 2, and 3, as well as Zookeeper persist its data. So these are all volumes that we mount into the containers. Now, if you haven't already, be sure to check out my Kafka in Docker Compose video where we take a look at all of this stuff in more detail. Now, the important part of Kafka is setting up a Kafka topic where messages are stored. And now with Kafka up and running, we're going to go ahead and create that topic called orders for our online ordering system. Our producers will be producing orders and sending them to that topic. Kafka will assign each of those messages to that topic, and we'll distribute these messages across 3 Kafka brokers using partitions. Now the next step is to go and create our topic called orders. Now to do that, we can exec into any one of the containers. So I'm going to say Docker exec, and I'm going to exec into the Zookeeper container. We can see that Zookeeper container is up and running. So I'm going to paste that to the terminal, and I'm inside of Zookeeper container. Now, as per our introduction video, we learned that Kafka comes packaged up with a bunch of helper scripts, and one of them is Kafka topics, which helps us to create a topic. So I'm going to create a topic. I'm going to pass the message to the Zookeeper instance. I'm not going to set up replication to keep it simple. So replication factor 1, partitions 3. So I'm going to distribute each message across 3 different partitions, 1 partition on each broker. So I go ahead and run the script, and this will create our topic called orders. Now, similar to creating, we can also describe our topic with the Kafka topics sh script, this time passing in the the describe flag and the topic we want to describe. So I go ahead and run that, and that'll describe our topic. The name is orders. It has 3 partitions. We can see it's not being replicated because replication factor is 1, and we can see where each topic partition is located. So we have topic orders. Partition 0 is sitting on replica 3. Partition 1 is sitting on replica 1. Partition 2 is sitting on replica 2. And that's a very simple partition on Kafka. Now with our topic ready, we can start sending messages to that topic and go ahead and build a consumer. Now more importantly, there are a number of ways we can consume messages in Kafka. By default, when messages come in, they are distributed across partitions. When consumed, they will arrive in random order because the messages are part of different partitions. When a consumer is scaled, the new consumer by default will get all the messages from the beginning and also read it in random order. Now to demonstrate this, what I'm going to do is I'm going to start up our Kafka consumer. So I'm going to change directory to the messaging Kafka folder, and then I'm going to say docker compose up, and I'm going to start up our Kafka consumer Go application. I'll copy paste that to the terminal. That'll go ahead and start up our container. Now the next thing I'm going to do is demonstrate messages being consumed in random order by default. Now to do that, what I'm going to do is I'm just going to split the terminal in 2. Then I'm going to change directory to the messaging Kafka folder in this new terminal, and I'm going to start up our producer. I'm just going to say docker compose up -d Kafka producer, and this is just a dummy Kafka instance because Kafka comes bundled with a producer script, and I'm going to use that to produce messages. And to do that, I'm going to exec into the Kafka producer container so that I can use that script. So I'm going to run that. Now I'm inside of that container, and the next thing I'm going to do is produce messages in a loop. So I'm going to write a basic for loop. My lower limit is 0, upper limit is 10. I'm going to loop from 0 to 10, and I'm going to just create messages using echo, and my messages are going to be in JSON format. So the ID is just going to be order with the ID, the number of the loop, and then I'm going to pass in some random data, and I'm going to pipe that to the built-in Kafka producer script. I'm going to give it my list of brokers to send messages to, and the topic called orders. So I'm going to generate 11 orders. So I'm going to go ahead and copy this, paste it to the terminal, and notice when I press enter that messages are coming in and being consumed by our consumer. Now let's take a look at the output of the consumer. We can see that it's consuming order 0, then order 1, order 2, order 3, and the messages are only coming in order because we've sent it in order, but order is not guaranteed. If we take a closer look from the start, we can see that the partitions are random. First message goes into partition 1, second message goes into partition 1, then the third message goes into partition 0, partition 0 for the following one, then partition 2, then partition 0. So we can see messages are assigned to partition in round robin fashion. This is because Kafka distributes messages by default to prevent all of our messages to go to the same broker. It tries to distribute these messages evenly. Now as we can see, the messages came through in order, but that's only because we wrote a loop that sends it out in order. Kafka does not guarantee order of messages by default, and we can demonstrate this by using the built-in Kafka console consumer script, which runs a small consumer as a shell script. It looks at Kafka 1, 2, and 3, looks at the topic order, and reads the messages from the beginning. So if we copy paste this to the terminal, we can see that the messages are being read out of order. We can see order 0, 1, 7, 4, 6, 2, 3, and so forth. This is because these messages are stored in different partitions. So when we read messages from a topic where the messages are distributed in different partitions, we'll get them in random order. Also notice that our consumer reads the messages from the beginning. This is because we've indicated from the beginning. We can also pass in an offset number to read the messages from a specific offset. This means we can either read from the beginning, or we can only get the latest messages, or we can remember the offset where we read up to. And when we restart our consumer, we can pass in the offset number and continue reading. Now this shows how messages are distributed in Kafka using partitions, and how messages are read in random order by default. Having multiple consumers also has every consumer get every message from the beginning in random orders. Now there's some noticeable challenges here. Number one, messages are read in random order. This is because partitions are distributed. To read messages in order, we have to pin them to a single partition using a key in our message. Now, to consume messages in order, we need to use keys in our messages. When using keys in our messages, Kafka will place each message with the same key in the same partition. And this is useful for event-based transactional systems where the orders of the messages is important. Now, if we take a look at our orders we've produced, we've started at order 0 and went all the way up to order 10. So to demonstrate consuming messages in order, let's create a message with a key. And in this example, let's create order 11 and update it 10 times. And in a transactional system, the order is going to be important. So we'll need to structure our message with a key to pin it to a partition. Now, to do that, we just need to structure our message a little bit differently. So this time I'm going to create the same loop. Now, instead of producing new orders, I'm going to produce new messages, but updating the same order. Now, to do this, I'm going to use echo and produce a message. But this time, take a look at the structure of my message. I still have the JSON here to specify the ID of my order. So I say my order is 11. I'm going to pass in generating some random data. But here is the critical part. In the beginning of the message, I'm specifying the key of the message. My key is going to be order ID, which is going to be order 11. And I'm going to have a separator of a colon followed by my actual message. And then I'm going to pass that to the producer script, send it to my broker list, to the topic orders as we did earlier. In addition to that, I'm going to tell Kafka about my property. I'm going to say I want to parse a key, and the key separator is a colon character, which we can see over here. So Kafka knows that the first part of the message up to the colon is going to be my key, followed by the JSON message. And because we're producing 10 messages, but every time passing in the same key, we're going to be sticking that message to the same partition. And when we read it, it will come in the same order as it was produced. So this is an example of an online ordering system where we have order ID 11, someone placed an order, and they're updating the order 10 times. Let's say the order goes through a production system. The first status could be pending, then in progress, then completed. So in this type of system, the order is very important. So let's go ahead and grab this and paste it to the terminal. And notice on my consumer what's happening. We can see this time we're getting all the messages in order, the offset is incrementing, but the partition is remaining the same. So if we scroll up, the first message of order 11 went to partition 0. That means every following message with that key will go to the same partition. So we can see every update to our order has gone to the same partition. And if I run the built-in Kafka consumer script now to read it from the beginning, we can see we firstly get order 0 to 10 in random order, and then we get our order 11, and we get it in the order that we produce those messages in. So the order here is guaranteed. Now that solves the first problem of message ordering. Now the second problem we've noticed is that the consumer by default will read all the messages from the beginning unless we pass in an offset ID. And this makes it challenging because every consumer has to remember where they read up to and store that offset ID somewhere. And if this offset ID is lost by an application, they will start from the beginning and consume all the messages again. Now to solve this problem, we can create what's called a Kafka consumer group. This allows us to scale our consumers, and Kafka will ensure that messages are distributed to each one of the consumers evenly. And it'll also remember where every consumer has read up to. So this allows us to scale our consumers up, distribute messages across our consumers, and when our consumer dies or crashes and gets recreated, they continue where they've left off, and they'll reconnect with minimal message loss. So let's go ahead and demonstrate this by building a consumer in Go. Now you can see if I stop the built-in Kafka consumer that I have here, and I rerun it, it will read the messages from the beginning by default unless I pass in an offset ID. If you take a look at the consumer on the left side, if I press Ctrl+C to stop it, and I press up to say Docker compose up, and I run it again, we'll see that it does not read all the messages from the beginning because I've used a concept called consumer group, which registers this consumer with Kafka, and Kafka will ensure it maintains the offset number. So to show you how to build a consumer, let's go ahead and create one in Go. So in my messaging Kafka folder, I have an applications folder. I'm going to right click, I'm going to create a new folder in here called consumer. And inside of this folder, I'm going to create a main.go. And this is going to be our our application. Now feel free to take a look at the README as I go through the entire process here. We're first going to say I want to build a package called main, and then I'm going to import all my dependencies. And the important one is the Shopify Sorama package to communicate with Kafka. So that's the SDK we'll be using. Then I'll be creating a bunch of environment variables. So I'll set a few variables, we'll read them from environment variables called Kafka peers. These are all the brokers we need to talk to, the topic that we need to produce messages on, the version of Kafka, as well as the group name for our consumer group. I'm going to create an empty function called main, and then we need to go ahead and declare our client config. So that's quite easy. We're going to create a new version here. We're going to pass the version of that environment variable for Kafka. Then we're going to create a new config, pass in the version, and then we're going to define our consumer group strategy. And we're just going to use round robin. This is in case we want to tell Kafka to rebalance our messages. It will use the round robin strategy to do so. And then we start with the initial offset, which is the oldest. We then create a context and we specify a new consumer group. We pass in the Kafka brokers as well as our Kafka group name and the client config to talk to Kafka. And then we handle any errors that might occur if we're unable to communicate with Kafka. So I'm going to go ahead and take the snippet, paste it into our main function. And now that we have our consumer group and our connection to Kafka, we're going to go and define our consumer. I'm just going to define a struct called consumer, and this goes outside of our main function. And we're going to be using a channel as well, so we can listen to messages coming in on a channel. And I'm going to go ahead and in my main function, I'm going to define that consumer. So I'm going to paste that down there. Now with that consumer, what I'm going to do is define a new wait group with a function that's going to be consuming messages as they come in. So I'm going to take this block, copy it, and I'm going to paste it into my main function. So what this is going to do is start up a wait group, add one task to the wait group, which is this go function. And here we're going to write an infinite loop. And the reason why we're writing an infinite loop here is in case a server-side rebalance happens, because the consumer session will be recreated by Kafka. So we need to be able to reconnect. So we're running an infinite loop, and then we're calling the consume function from the Kafka client. We pass in the topic we want to listen on, and we pass in our consumer. And that is basically how we will listen for messages coming in. We'll then go ahead and print to the terminal to say our consumer is up and running. And next up, let's handle some exit signals in case we want to exit the container. If you're running in something like Kubernetes, you want to make sure you're always managing exit signals so that you can finish consuming messages and shut down gracefully. And to do that, I'm going to create a new channel called sigterm, and I'm going to call signal.notify. And then I'm going to run two select statements. One is if the context is cancelled, I'm going to say context.done, print that to the terminal, or if we're just terminating via a signal. And if there's any errors on closing the client, I'm going to print that to the terminal as well. So we're going to copy this block and paste it in our main function. So that's the code for handling exit signals in case we want to shut down gracefully. Now the Sorama library requires us to handle additional functions. One function we can just paste into our code is the setup function, which helps us set up that session for the consumer claim. So I'm just going to copy that and paste it into main.go just below our main function. In addition to the setup function, we also have a cleanup function, which runs at the end of the session. So I'm just going to paste that one below the setup function. And finally, the useful function, which is the consume claim function. That is where we can actually consume the message and take action. So I'm going to copy this function and paste it in my main.go. And let's take a look at this function. So the function is called consume claim. It takes in the consumer group session as well as the claim. And what we do is we say for each message and we loop through the claim.messages function. And then we can access the fields on the message. So what I'm going to do here is I'm just going to print out all the useful data about the message. So message.partition, the offset number, the key of the message, the value of the message, as well as the topic. And that's it for the code for consuming messages using the Sorama library. Now to get this consumer built, we're going to need a Docker file. So in the Messaging Kafka Applications consumer folder, I'm going to right click, create a new file called Docker file. And in here, I'm just going to paste the small snippet from our README, which says I want to start from Golang as my dev environment, and I'm going to install some Go dependencies, mainly Git for dependency management. And then I'm going to specify my working folder called app. This small Docker file will give us a Go development environment where we can actually mount the code we've just written in, and we can run go build to produce a binary that we can run. Now to build the code we've just written, let's go ahead and change directory to the messaging Kafka applications consumer folder, because that is where our Docker file is located. We can see it's right there, followed by our main.go. To build the container, I can say docker build dot, and I'm just going to tag it as consumer. That'll just go ahead and build the Docker file, which is just Golang with some dependencies and our working directory. Now with that container built, I want to run it, mount in the code, and set up our Go project so we can download our Go dependencies and build out our Go container further. So to do that, I'm going to say docker run -it. I'm going to mount the working directory into that app folder that we created on the left here in our Docker file. And I'm just going to run the consumer image we've just built, followed by a sh command. So I'm going to copy that, paste it to the terminal, and now I'm inside the Go container. I can do ls -l, and we can see we have our Docker file and our main.go. I'm going to run go mod tidy. This will go ahead and find and download all the modules we've defined in our Go application. Once we've done that, I also want to define a Go module called consumer. Say go mod init consumer. We can see that already exists. And on the left side here in our folder, we have a go mod file and a go sum file, which defines all our dependencies in our code. I can now run go build, which will build our application. Now I ran go build, and we can see that's done. And we have a consumer binary on the left that we can start. So now we have our go mod and go sum file, we have our code compiling. So let's extend the Docker file so we can run our full application as a container. So the first part is just the dev environment, which is our Golang container we can use for development. What I'm going to do now is extend it a little bit further by saying from the dev environment we created up here, create a new layer called build environment. Copy in the go mod into the application folder, and then say go mod download. That'll download all the dependencies into this layer so that when we change our code, we don't have to run go mod download all the time. So it's using Docker multi-stage. After we've downloaded all our dependencies, I just say copy the rest of the code into the app folder, and then I run the command required to build our application, which is go build, and produce a binary called consumer at the root of the container folder. Now that's for the build layer. Once that is all built, we have our binary. We want to produce a lightweight container we can run in production. So to do that, I'm going to start a new layer called Alpine 3.10 as runtime. I'm then going to copy in from the build environment our consumer binary we've defined up here, and I'm going to copy it to user local bin. And then I'm going to run something else in Linux that's required. In order to execute that binary, we have to give it execution rights with chmod, and then define an entry point for the container, which is called consumer. That'll run our consumer application inside of this container. So now I can exit out of this container, and to build the entire container, what we can do, rather than running docker build, we can go to our docker compose file. And if I collapse everything we have in here, we can see I have a new section here called Kafka consumer-go. I pass in a container name, I give it a tag, we give it a build context where our Docker file is, which is in the messaging Kafka applications consumer folder. You can see I give that full URL over there. We pass it environment variables it's going to need to connect to Kafka, the Kafka topic, the Kafka version, as well as the group. And I'm just going to call the group orders. And then I also specify I want to run this container on the Kafka network so it can talk to the Kafka instances. So to build this container we've just created, we can go 2 folders up to the messaging Kafka folder, because that's where our Docker compose file is located. And we can say docker compose build and pass in the name of the container we want to build. That'll go ahead and build the Docker file we've just defined. And finally, to see our consumer in action, I can say docker compose up Kafka consumer go, and we can see our application is up and running. And notice it does not read from the beginning because it's already registered with Kafka as a consumer running on a consumer group. To demonstrate that it works, I can simply run from the producer container. I can run that producer script we ran earlier and produce order messages, and we can see they're being collected on the left hand side here. Hopefully that gives you a sense and understanding of how messages are consumed in Kafka and how to build your own consumer. If you liked the video, be sure to like and subscribe and hit the bell. And if you'd like to support the channel even further, be sure to check the Patreon link down below or become a YouTube member. Also be sure to check out the community page in the description down below. And stay tuned for more videos about how to run Kafka in something like Kubernetes. And as always, thanks for watching, and until next time, peace.